Have you ever pondered how our understanding of the tiniest particles in the universe, atoms, has evolved throughout history? Today, we're embarking on a journey through time, tracing the evolution of the atomic model from the philosophical musings of the ancient Greeks to the complex quantum mechanics of the modern age. In the beginning, there were the ancient Greeks. Around the 5th century BC, philosophers like Democritus and Leucippus proposed a bold idea. They suggested that everything in the universe was made up of tiny, indivisible particles called Atomos. These Atomos, they believed, moved through empty space and combined in different ways to form all the materials and substances we see around us. Fast forward to the early 19th century. Enter English scientist John Dalton. Dalton built on the Greek concept of atoms, but added a twist. He proposed that atoms of the same element were identical in mass and properties, and different elements had atoms of different weights. This became known as Dalton's atomic theory, the first scientific atomic model. Next, in the late 19th century, Thomson, an English physicist, discovered the electron. This subatomic particle was much smaller than an atom and carried a negative charge. Thomson proposed the Plum pudding model, where atoms were spheres of positive charge with negatively charged electrons embedded within, like plums in a pudding. Ernest Rutherford, a New Zealand physicist, challenged Thomson's model in the early 20th century. He conducted an experiment where he bombarded thin gold foil with alpha particles. The results led him to propose a new model, where most of an atom's mass and positive charge was concentrated in a central nucleus, with electrons orbiting around it, much like planets around a sun. Then, in 1926, the young physicist Schrödinger introduced a revolutionary idea. He suggested that we should not think of electrons as particles moving in precise orbits. Instead, he proposed a model where electrons existed in clouds, or orbitals, around the nucleus. Their exact location at any moment could not be pinpointed, but could only be described by a probability. This quantum mechanical model is the one we use today. It incorporates the principles of quantum mechanics and accounts for the dual nature of matter and energy as both particles and waves. So from the ancient Greeks to the quantum physicists of the 20th century, our understanding of the atom has evolved dramatically. It's a testament to the power of human curiosity and our relentless pursuit of knowledge. And who knows what future discoveries may yet reshape our understanding of the atomic world. As always, science continues to move forward, and with it, our perception of the universe we inhabit.